Hi everyone, my name is Hagay Lupesko. I'm here with my colleague Margaret Qian. We're from the Databricks engineering team building our Mosaic AI product. And today we're going to introduce you to two generative AI models designed, trained, and served on Databricks. We won't just introduce these models, we'll also get into the details of these models and share how you can leverage these models today for your business and your needs. So the first model we'll talk about is DBRX. It's a state-of-the-art, efficient, open language model. We actually open sourced and introduced a couple of months back. The second model, which was introduced earlier today in the keynote, is Shutterstock ImageAI. Shutterstock ImageAI is a text-to-image diffusion model that is commercially safe and designed to generate high-quality images for enterprise use cases. Now, we'll get into all the details of these models later in this talk, but what's really kind of a key thing to highlight, both of these models were built for the enterprise by the Mosaic AI research team and trained and served on Databricks Mosaic AI. And what's also is in common to these two models is both of them were designed from the ground up to be used by enterprises. They're safe, they're performant, and they're highly efficient. All right. Okay, so just before we get started with the models, GenAI is all the hype these days, but just to set a good baseline, let's just start with a quick introduction to generative AI. Okay, so when you look at the kind of arc of time in history, modern AI started in the 50s. Turing proposed a Turing test back then, and McCarthy was one of the geniuses of the time, coined the term artificial intelligence, and that's where it all started. Since then, we went through symbolic AI, which was a huge promise, had a huge hype even outside of the AI community, but then didn't really deliver on everything it promised. And then we went through AI winters in the 80s and 90s, where the AI field saw really a significant drive of investments. And then things started picking up again in the 2000s. The internet broke into everyone's lives, huge data set became available, online applications became very successful. And this really set up the stage for machine learning and later deep learning coming in the late 2010s when we had convolutional networks for computer vision, we had RNNs for NLP, and things started really picking up. And this brings us to present time, the era of generative AI. One specific deep learning architecture, the transformer, which was invented by Google researchers originally for language translation tasks, and that's still what powers Google Translate, by the way, started producing really groundbreaking results in things like text understanding, image understanding and generation, speech generation and understanding, and many other fields. Recently, the world got access to ChatGPT, and I think never looked back after that. So applications of generative AI, how is that useful? Well, as it turns out, the ability to deeply understand and generate content, not just language, but also images, video, speech, and other mediums really opens up tons of capabilities. We have e-commerce where GenAI already optimizes product descriptions, generates compelling product art, and even automates customer support. In finance, we have today language models such as JP Morgan's Index GPT. It's a model that is already helping customers make investment decisions, answer financial questions, and analyze financial reports. In creative design, we have GenAI powering creation of art and marketing materials, and tools like Adobe Sensei, Jasper, and Writer are already used by hundreds of thousands of people. And then lastly, even in software engineering, which is a field many of us have been practicing for a while, GenAI is boosting developer productivity with tools like GitHub Copilot, and even on the Databricks platform, we have the Databricks Assistant, which if you haven't had a chance to try it out, please do. It's a great assistant for helping you write better code within the Databricks platform. And this is just the beginning. New applications and use cases are coming up daily. And if you look at adoption, MIT data suggests that 91% of organizations are already experimenting with GenAI. 3 out of 4 CEOs today, according to data collected by IBM, already say that they believe that GenAI offers a competitive advantage for their companies. So the opportunity is here, the opportunity is real, and all of us at Databricks want to help you, our customers, leverage an AI quickly and effectively for your business. And with this in mind, I'm handing the mic to my colleague Margaret to tell you about ImageAI.
Yeah, so as many of you might have seen during the keynote today, we are introducing ImageAI, which is our newest foundation model. It is a text-to-image model, and I just wanted to kind of start off and point out that all the image generated on the right of the slide here, they're all from the model, and so just take a minute and appreciate like how good the quality is. So yeah, the Shutterstock ImageAI powered by Databricks. I wanted to highlight like 3 key features of this model. One is quality. So this was trained on over 550 million photos. And really, I think what makes this model stand out is that all the data is from a trusted data source. So we worked with Shutterstock and we used their proprietary image repository, and all of their data is licensed. And so you can be confident that the model is generating images based on data that is safe for enterprise use. So also, as you can see, like the photos are generated in very high resolution, they're photorealistic. And so that kind of goes to show that this model was designed with quality in mind. Next, we have safety. So like I kind of mentioned, the data set was carefully curated for corporate use. So that kind of results in a model that is safe and good for enterprise use. And lastly, this model is available through the Databricks platform. And so with the Databricks platform, you get all the governance that comes with using our product. And so these are things like rate limits, admin controls. You also get monitoring. And so that's another thing that I wanted to highlight about this model. So now that you know what this model is, now how can you access it, right? Like I think we're all pretty excited about the demo during the keynote. These are some amazing images. Now how can you generate your own? So it is available now on the foundation model APIs on Databricks. It is 6 cents per image. And it is the easiest way for you to get started with this is through our AI Playground. So Playground, if you haven't tried it out, it is our UI environment for basically experimenting with models, like quickly iterating. And so we've kind of expanded our offering. It used to support text in more of like a chat format, so we've expanded that to support images as well. And another thing that we kept in mind was like one of the more popular clients out there is the OpenAI SDK, and so we designed our API to be compatible with that. So if you're playing around with any other image models out there, you can really quickly swap out our endpoint and get started that way. I also wanted to highlight we did keep performance in mind, and so on the best hardware, we're getting around 3 seconds per image, and the size options that you can choose from are square, landscape, and portrait, and the resolutions are on the screen here. So that is what we have now, and we're super excited about this, and so we're working on some additional support on our platform coming very soon. And so you can customize your own model via fine-tuning or pre-training, so that is the next step. And also, if you would like to deploy this model for, more production use cases, or you want higher throughput, we also are going to add the option to deploy this model via provision throughput. But like I mentioned, here's just a code snippet of how easy it can be to get started with the OpenAI SDK. I do want to kind of clarify that we are using the OpenAI SDK here as just a simple example. We are not affiliated. This model is not affiliated with OpenAI. But as you can see, there's just a couple of parameters that you need to pass in order to use the API. You can pass in the prompt. I have an example of a cozy corner with a warm fireplace and a comfy chair, and the model name, and then some extra body parameters. These include negative prompt and seed. So these values help you control the generation of the images, and I'll explain a little bit more like what each parameter does in a later slide. But this is kind of just our simple example to show you how easy it is to get started with our APIs. So with that, I'll actually show a demo using Playground, which I kind of mentioned earlier. So Playground, this is the UI, and we kind of have some nice examples that we've tried out that generate cool images. So if you don't know really where to get started, you can start off with one of these examples. We also have parameters here. So the size, like I mentioned, there's a couple different options, and you can choose from square, landscape, portrait. There's also the number of images that you'd like to generate. For this demo, I'm just going to generate one image. And there's also a seed parameter, which kind of controls the randomness of what is being generated. And with that, you know, I'm just trying to generate maybe something simple, something like I like to, you know, drink day to day. So let's say I want to generate an image of a cup of green tea. So naively, I would think like I could start off with this prompt. And let's see what we get with that. So here, kind of zoom in a little bit. Everybody can see that. This is a very nice cup of green tea. It generated an image based on this prompt, but I think I wanted to be a little bit more specific. And so I just kind of want to show you like how you can modify the prompt a little bit to make this generate something a little bit more specific, a little bit more detailed. So I'm thinking this top-down view is a little bit boring. I want something more dynamic. And so I can try something like green tea pouring into a transparent cup. So one of the nice things is you can kind of describe the style of the image you'd like to generate. So you can say something like marketing concept. You can also ask for a simple background. So in this case, I do like how the background is just like, you know, one color. It's pretty simple. It doesn't take away from the foreground, so I'll keep that. And then I will try to generate some tea leaves on the table as well. And, you know, let's see what we get with this. So kind of zoom in again here. And yeah, I feel like this image generated is exactly what I've asked for. There's a cup of tea. It's in a transparent cup. There's tea leaves on a table, and there's a very simple background. And for the marketing concept portion, I feel like this kind of image can be easily used for, you know, brochures or just marketing material in general. So I think it's pretty accurate here. Lastly, I just want to show there's also this code example pop up here. So the exact prompts that I've tried out, you can also just copy this code snippet. And this is the Python example as well. And these help you get started really quickly if you're trying to write this in a script or something else after you've played around with it in Playground. Awesome. So now that I've shared a little bit, like a sneak preview of what you can actually generate with this model, I wanted to talk a little bit about how everything works under the hood. So these next couple slides are talking about the overall architecture of this model. And it's really composed of two main components. There's a text encoder and an image generator. So we'll start out with the text encoder. And the input to the text encoder portion is the string input. So if I'm going back to my example, a cozy corner with a warm fireplace and a comfy chair, this gets fed into the first component, which is a tokenizer. And the tokenizer here splits the input string into tokens that the text encoder can then consume. The example I have, you can see that the text, like the tokens, don't exactly correspond to the text words one-to-one. We will inject kind of special tokens like a start token to dictate the beginning of a sequence. There are times when a word can be chunked into two for the tokenizer. So this is all up to kind of how the tokenizer is built. And one thing to call out here is we actually truncate the input to 77 tokens. So if a input is too long, we'll truncate it to 77 tokens. If it's too short, we actually pad it to 77. And that just kind of makes everything a little bit more performant, a little bit easier for the text encoder to process. And the output of the text encoder here is a vector, and the size is 77 by the size of each embedding. And each embedding here is 768, that's the size. And from there, you can go back to the overall architecture and look at the image generator portion. So the image generator portion takes in that embedding vector that the text encoder portion output. And this is kind of where the magic happens. So the images are generated in a iterative diffusion process, and this essentially takes a noise, and it iteratively kind of refines that noise until you get the final image that is representative of the prompt that is inputted. I have on the slide here showing this process in the image land, but actually for performance reasons, these images are generated into latent space representations first. But overall, the idea here is that you start out with full noise and you have this UNet. And the UNet is a neural network that basically predicts at every time step what noise to subtract from the initial input. And it's conditioned based on the prompt. So the prompt helps the model predict what noise to remove. And at every step, you subtract some noise, and you subtract some noise, and then eventually you get this final image. And before you get the final image, like I kind of mentioned, since we're working in latent space here, you need to first convert that to the actual raw image format before you can see it. So that is the overall process. And kind of wanted to illustrate some prompt engineering tips and tricks based on a simple scenario here. So let's say I work for an animal adoption center, and I'm trying to create a brochure, but I have a pet at home. For anybody who has pets at home, we all know how difficult it can be to take high quality photos of our animals. And so if you try at home, you might end up with something like this. And this is my cat. I love him so much, but I don't think I would put this photo on a marketing brochure. So let's see if we can try to generate a high quality photorealistic image using the ImageAI model. So kind of how I started with the demo earlier, you can try starting out with a pretty naive prompt. So here we have a cute cat. And you can see this is a very anatomically correct cat. It's also very cute. But the background is a little bit messy, and I think the composition could be improved. And so I'll show you how we can make this better with prompting. So the tip here is to add photorealistic modifiers to your prompt. So in this example here, these modifiers are words like portrait photograph, prime lens. To describe lighting, you want to use stuff like studio lighting. And for the composition, I've added more details. I want this cat to be on a cat image to be on a white background. And as you can see, the result is a lot more clear. The lighting is consistent. The background is indeed white here, and it does look like it was a photo taken in a studio. But I think I want to kind of see what the model can get me that I couldn't necessarily get in a studio environment myself. I want to see if it can get more creative here. And so I have gotten very much more creative here. And the tip that I wanted to share here is we can use keywords in the negative prompt to specify things that you don't want in a photo. So this is stuff like blurry, ugly, deformed, amateur. And as you get more creative, the model, it was trained with both photorealistic images, but also vector and illustrations. And so I kind of added vector and illustration as keywords of things we don't want to see in the photo. And so, yeah, we have a very unique hero image, and it's very creative, and I'm pretty happy with it. And just, I don't know, in case folks can't see it in the back there, the prompt is a cute cat jumping in a colorful cyberpunk setting, blurry neon signs in the background, professional quality, good photo. So I just kind of wanted to end with a couple other examples from the ImageAI model. You can see they're all very high quality. There's definitely the photorealistic element to these photos, and the prompts are also attached to these photos, so you can see how we generated these. And with that, I'd like to pass it back to Hagay.
All right, amazing to see kind of the images and just to think what people can do with the model. So, all right, now talking about DBRX. So DBRX is open source, state-of-the-art LLM. We actually open source and announced this model a couple of months back, and to great really reception in the community. We have two versions of DBRX out there that you can use today. One is DBRX Base. DBRX Base is the baseline model, functions like a smart autocomplete, and it's great as a baseline for fine-tuning on your own data, and we'll talk about that a bit later. The second one is DBRX Instruct. That's a version of DBRX we have fine-tuned ourselves with instruction following, general purpose instruction following data, and it's great for following instruction in your own task, and of course you can also fine-tune it further yourself. All right. I want to talk about four kind of main aspects of DBRX I think are useful for you to know. And, you know, it's open, control, quality, and performance. We'll talk about each one of them before we actually look into how you can use the model. So in terms of open, as I mentioned, DBRX is open source all the way from the model architecture to the weights. It's freely available on GitHub. You can check it out on Hugging Face. And it has a commercially permissive license. So you can use it for research, but you can also use it for your own production use cases. The other thing that is useful, and we talk about in a minute, is the fact that it's open really makes it very easy to customize. And let's talk about what this means. So this really comes down to control. Unlike closed models, the fact that DBRX is an open model really makes it very easy and available and accessible for customizing it on your own data. I don't know if you've noticed this throughout both the keynote and talks. We at Databricks really believe that for AI to be useful, it needs to be customizable for business use cases with the data that businesses have. There are two main ways you can customize DBRX. One is fine-tuning it, and fine-tuning it allows you to specialize it for a very specific task. Control the model behavior so it answers specific questions and maybe does not answer other questions or answer them in a certain way. It also allows you to reduce inference cost and latency because when you fine-tune a model, you can actually get really good performance for that use case with a smaller model. And the other thing is you can actually condense the size of the prompt, which again reduces cost and reduces latency. The other main way is pre-training DBRX, and you do that if you want to tailor the model to something like a new language. Maybe there's a low resource language that the model is not good at, or other models also not good at, and pre-training DBRX on that data allows you to get the model to perform well on that language. Sometimes it's even a domain, like the legal domain or healthcare. These domains tend to have also special languages, and pre-training on that data helps you get a model that is very performant on that. And then the other thing, you can also fully control the training data. Some businesses in some industries are not willing to have models trained on data that is just scraped from the internet. So with pre-training, you can fully control the data. In terms of quality, DBRX is one of the highest quality open models available today. It was trained on 12 trillion tokens of carefully curated text and code. It supports context length of up to 32K. As you can see in the chart here, when you look at the performance of the model compared to other leading open models, DBRX is very performant. You can see here metrics for language understanding, MMLU, coding with human eval, and math with GSM-8K. Even when we compare DBRX to closed models, in this case it compares DBRX to GPT 3.5, DBRX is performing well. And lastly, on quality, as I mentioned earlier, we had great response for DBRX from the community. And here, I hope you can see, but this is sort of anecdotal feedback from Twitter, where a practitioner evaluated DBRX against GPT-4 on a very practical customer support task that was customer support summarization, and published the results. And you can see that DBRX was actually on par or better than GPT-4, although being much cheaper to serve. Now, performance. Last but certainly not least, we know from you guys, from our customers, that when you consider enterprise AI use cases, performance is really critical because you both want to ensure a really good user experience, and performance is important for online interactive use cases, but it's also important because you want to keep serving costs down. And with this in mind, we actually designed DBRX from the ground up with this in mind, and we chose an architecture that is, we call it fine-grained mixture of experts architecture. There is a diagram here actually taken from a Google MOE paper that kind of explained the architecture. I won't go into the details, but I'll just say at every transformer block, you have a router and then a set of experts, and at every forward pass, only K out of total N experts are being activated. This effectively reduces the number of floating point operations happening in the forward pass, as well as backward pass when training. But what happens is that you just have less compute happening, so inference can be faster. In the case of DBRX, out of a total of 132 billion parameters, only 36 billion are active at every forward pass. And this basically makes DBRX 2 times or more faster than dense models without MOE, dense model with similar quality. And we're actually able to get about 150 tokens per second with DBRX inference using quantization and a bunch of other optimization techniques. And then another kind of anecdotal, we love Twitter, so another anecdotal feedback from a practitioner on Twitter, where basically this practitioner evaluated different models and categorized them into quality tiers. And you can see here that DBRX is in the intelligence tier alongside other great models like Gemini Pro and GPT-4 Turbo. But compared to that tier of models, DBRX was found to offer the best performance and cost. It was 50% cheaper than other models in this category and 100% faster. So that trade-off between quality and performance is what we were aiming for, and we hope we kind of were able to get good results. Now let's dive into how you can actually use DBRX on the Databricks platform today. There are 3 main ways: serving, fine-tuning, and pre-training. I spoke about fine-tuning and pre-training a little bit. Serving, you can access DBRX today on the foundation model API. You can easily use paper token with very competitive pricing, and we recommend that for experimenting with the model, building POCs, kicking the tires. And then you also have the access to provision throughput, which we recommend for production-grade serving, where you want availability, you want SLAs, you want guaranteed throughput. And over there, you pay per the hour for certain throughput tier. And of course, you can purchase multiple throughput tiers. Fine-tuning is, can fine-tune DBRX today with the foundation model training service. You pay per DPU, and it's really surprising to customers, whenever I talk to customers, how accessible in terms of cost fine-tuning is. So for fine-tuning DBRX with 10 million tokens is going to cost you about $193. And you can actually do pretty good fine-tuning with 10 million tokens. If you notch it up a little bit, 500 million tokens is going to cost you a little bit under 10K. And you get your own model fine-tuned with your own data. And then lastly, pre-training, that's the most expensive option, but one that actually allows you the fullest control of the model. That's available on MCT, Mosaic's multi-cloud training. And of course, the cost varies with model and data scale, but we actually are offering you different sizes of DBRX to pre-train. The smallest one, DBRX 9B, to fully train is going to cost you about 40K. And of course, the larger the model is, the more data, the higher the cost will become. So just like Margaret showed earlier with the ImageAI model, you can actually run inference today. We know that the OpenAI SDK is highly popular, so we made our endpoints compatible with it, and you can actually use the OpenAI SDK to access the model on Databricks platform. No data goes to OpenAI, obviously. It's just the client SDK that you're using, and you can see the code example here. Let's do real quick demo here. So this is our staging environment, and you can see the Mosaic AI tab. And by the way, that's where we kind of try to highlight capabilities that are of interest for you, and DBRX indeed shows here. And you can go to check out the details of DBRX Instruct available if you're curious about more details about the model, but you can also just click here, and we go to the playground. The playground, as Margaret mentioned, is an interactive web experience where you can just play around with our models and capabilities and try things out before you actually get them into your code base. And to make things easy, you can see different models available here. I'll choose DBRX Instruct. We have a few examples just to show some kind of the capabilities or the things you can do with DBRX. One of them is sentiment analysis, providing a tweet, classifying the sentiment as positive, neutral, or negative, and you can see the model responded, classifying the sentiment as neutral, which is fair. Unstructured text parsing allow you to take a bunch of text, document, and then parse it into JSON or any other format you're interested in. That's another very common use case for DBRX and other language model. Summarization, which takes a long document and summarizing it. And lastly, document question answering. Take a large document and then fill the question on that document. Those are all kind of common use cases. Prompting, just like with image generation models, also with language models, prompting is important. I just want to kind of show just a little bit of how you use the playground to experiment before you actually deploy it in your code. So in this case, we're asking the model to analyze the sentiment of a review for a movie. And the model does a good job, but this is not really something, this response is not something we can actually use in an application because it's not structured. So one thing we can do is I can just copy this thing, and I can ask the model to actually provide a JSON back. So find JSON, and you can see that the model responds in JSON, sentiment neutral. I can actually, if I want this to even render a bit nicer, I can ask it to use Markdown, so it also looks nicer in this UI. So it's nice to see how the model is following my instructions. Now I can even take this a step further because I may want to add other things. So I can ask it include the following fields. I can ask it to include input. I can ask it to include sentiment. I can even ask it to include confidence. Confidence interval from 0 to 1. And then lastly, I can even ask it to produce a rationale. Why did you classify this sentiment in the way you did? Which is useful if you have a human in the loop, which sometimes you do. So, all right. And you can see the model followed my instructions pretty well. Input, we have the input, the sentiment, the confidence interval, 0.95, and then the rationale, that the word meh indicates a lack of strong positive or negative emotion. Looks pretty good. The next thing you'll want to do is you want to take this thing and actually use it in our application. So we have the code tab here. go to Python, copy this, and you can just take it into your code, and I can just spin up quickly a Databricks notebook, and I can actually run this code here and get the results. Now, I think this should work, right? We are importing OpenAI token. Let's run this and let's see what happens. Okay, so there was execution failure. Looks like this statement had an error. And what's nice is that the Databricks assistant automatically kicks in, looks at the error, and actually tells me, hey, you need to install the OpenAI package, which is good catch. I missed it. So I'll just run this. And while I'm at it, while it's loading, I do need to also restart my library so that this new model available is there. I'm also spotting that I need to uncomment this because I'm running a notebook, and then I will run the code and we'll wait for the response. And indeed, we have the response. So very easy to use, accessible on the Databricks platform. Cool. All right. Fine-tuning. So you can use the Python SDK or also a web UI we have available in the Databricks console. The fine-tuning SDK is fairly straightforward. You install and you import the PyPy package, set the training data path, and just create your fine-tuning job. You can choose between 3 tuning tasks. You can do supervised fine-tuning, which trains DBRX on structured prompt and response data. You can do continued pre-training, which trains DBRX with additional text data. And you can use this to add new knowledge to DBRX or focus it on a specific domain. Or you can also fine-tune it for chat completion. Those are user assistant query and response chains. You can use all of that to fine-tune DBRX. I don't have too much time, so I'm just going to show you real quick the user interface for that. So on the left nav, on the machine learning experiments, we now have foundation model training. You can create experiments, and this is the user interface presenting what I just shown in the SDK. Chat completion or continued pre-training or instruction fine-tuning. Choose DBRX or other models that are available here. Data, just choose the data from within Databricks and the location you want to register your model for. Once fine-tuning is done, the model will be available for you on the Databricks platform for deployment. All right, and last but not least, pre-training DBRX. That's the third option I mentioned earlier. Over there, the interface is also pretty straightforward. You define a configuration file that includes the size of DBRX that you want to pre-train. And you can choose between 4 different sizes of DBRX, from 9 billion to 73 billion parameters. All of these are a mixture of experts model. You point the training data bucket, the folder to save the model into. You define your experiment tracking system, and in this case, it showcases MLflow, but you can also use other, like weights and biases or comment ML, and the number of GPUs you want to run on, and then you just run the mcli train command. We handle everything else for you, from orchestrating the job across hundreds of GPUs to handling GPU node failure, collecting the metrics, as well as exporting an optimized model available for you on Databricks where you can serve it. I'm not going to demo this here because we don't have enough GPUs at the moment, but and this is an example of, this is actually a real example from one of the DBRX training. You can see an MLflow, and this kind of change in colors is actually when there were GPU failures and the system handled them automatically without anyone even bothering about it. All right, so we're close to the end. Just recapping what we've discussed in this session. So we introduced the Shutterstock ImageAI model, our new text-to-image diffusion model. as well as DBRX, a state-of-the-art, efficient open language model. Both of them were designed from the ground up to cater to the needs of enterprise companies, and both are available to you today on Databricks Mosaic AI. We hope this session was useful. Thank you, Margaret, for an awesome intro to ImageAI. And we're excited to see what all of you are going to build with these models and the Databricks platform. Thank you.